Assalamualaikum warahmatullahi wabarakatuh. So, we are from Group 7 and now we're presenting to you about bioethanol production from onion waste. Let me introduce myself first. My name is Cik Rushafika Izzati binti Cik Hassan and my member's name is Siti Masya Amelia binti Supriyati Rahman, Nurul Fatihah binti Abdul Nasir and also Ni'imah Nuraini binti Nurul Farizan. In this topic, we will explain to you roughly about the agriculture waste and why we choose the onion, and we also will explain to you about the fermentation process, sustainability consideration, and advancement or process improvement. In this topic, we are producing bioethanol from agriculture waste. So, agriculture waste is a waste that are produced from farming activities and also agricultural production process. So there are several types of these agriculture waste, which is crop residues, animal manure, fertilizers, pesticide contaminants, and also byproduct of agriculture practices. In order to produce bioethanol, we are choosing onion skin because it mainly contains water and simple carbohydrate with a low lignin content. Besides, high impact development and also cost effectiveness biorefineries can utilize the sustainable agriculture waste, which can help realize the circular bio-based economy opportunities along with the advancing technical viability. Moreover, onion skin also have high conversion rate of sugar and it doesn't require any pre-treatment. Other than that, when we transfer the onion skin to the landfill, the degradation process will release methane. So, in order to mitigate this problem, you can use the onion skin as a source to produce bioethanol, as well as reducing the environmental pollution issues. So, the table on the side is show the conversion rate of sugar, whether it is soluble or insoluble.
So, in this slide, I'm going to explain the fermentation process occurs during the production of bioethanol from the onion skin. So first of all, we need the onion, and then from the onion, we're going to take the onion waste, which is the onion skin. So why is onion skin is used? Because of onion skin is rich in lignin. So the lignin itself contains a lot of carbohydrates, which can be a good sources to convert into fermentable sugar. So from the onion skin, it does not require any pre-treatment, and it can directly undergo enzymatic saccharification. Okay, so in this enzymatic saccharification process, the onion skin will undergo enzymatic saccharification process, which enzyme like amylase will be used to break down the lignin content in the onion skin. This is due to the lignin presence in the onion skin make the fermentation is not accessible, especially to the yeast. Okay. So when enzymatic saccharification is done, the lignin have been break down by the amylase, and then it will make the process. It will make the fermentation process will be easier, and it can produce a high conversion rate of the fermentable sugar. So during the fermentation process, yeast, which is Saccharomyces cerevisiae, will be used to enhance the fermentation process itself. The yeast will help to convert the fermentable sugar into bioethanol and carbon dioxide. For instance, fermentable sugar or the monosaccharide, for example xylose and arabinose, produced from the enzymatic saccharification process will be consumed by the yeast, and then it will be convert into ethanol and carbon dioxide.
As we know, bioethanol is a renewable fuel derived mainly from plant materials such as onion skins, sugarcane, or biomass. So we can blend or we replace conventionally fossil fuels with bioethanol because we can reduce our dependence on fossil fuels, and it also can lower greenhouse gas emissions as bioethanol conversions release less carbon dioxide. Besides, bioethanol also contributes to long-term sustainability by utilizing renewable resources like onion skins or agricultural waste, which can be replanted. Unlike fossil fuels, which are finite and depleting, bioethanol production supports a circular system where carbon dioxide absorbed by plants during growth offsets the emissions during combustion. Next, food security also concerns in bioethanol productions because when we use feedstocks as fuel, that can reduce food availability, increase price, and affect vulnerable populations. Therefore, it's important to explore non-food source like agricultural waste or algae to balance energy needs and food security. When we talk about energy balance,
So we chose biorefinery for a process improvement in bioethanol production by using onion. Biorefinery can be defined as the refinery used to convert the biomass from living organism into a bio-based product or bioenergy like chemical and fuels. So in bioethanol production from onion, it contains a several steps involving pre-treatment to prepare the onion skin, fermentation by using yeast in the conversion of sugar into ethanol, and the process of distillation in order to purify the ethanol. There are some advantages when we use biorefinery in the production of bioethanol by using onion, which is a separate circular economy. So biorefinery is one of the aspects which can support circular economy. The plant will store an energy in the form of chemical energy and it will be dissipated in the form of biomass. So the objective of biorefinery is to harness this stored energy in order to maintain sustainability. The second one is maximizing resource efficiency. So onion skin and other waste product from onion is being used because it is a sustainable and abundant feedstock. This factor is to maximizing the resource efficiency. And the third one is minimizing environmental impact. So when we use onion, we can minimize the impact to the environment because it requires no pretreatment. So no hazard chemical use in this process.
So in this slide, I'm going to explain the flow diagram of a biorefinery process, which is an advanced treatment to produce bioethanol from the onion skin. Okay, so first of all, biorefinery is a process or an advanced treatment which utilize the biomass to convert it into some value-added product. For example, to produce bioethanol or maybe synthetic gas. So in this process, first of all, the feedstock will be collected from the agro waste, for instance from the food processing industries. Then the feedstock, which is the onion skin, will undergo the alkaline treatment. For instance, using H2SO4, the sulfur acid, to break down the lignin. Because of in vegetable, for instance onion, the lignin content is higher. So when the lignin content is high, it will inhibit or it will make the fermentation process is not fully accessible for the yeast. Then after the alkaline treatment, the onion skin will undergo the enzymatic saccharification process, which is a process which using some enzyme, for instance cellulase or hemicellulase, to break down a component from the onion skin. For example, cellulose and hemicellulose, in order to break down the polysaccharide into monosaccharide. So monosaccharide is a simple sugar that can be used in the fermentation process. So during the fermentation process, the monosaccharide, for example xylose and arabinose, can be easily converted into bioethanol by using Saccharomyces cerevisiae, which is yeast. So yeast is responsible to consume the sugar and then convert it into bioethanol and the carbon dioxide. Okay. So from this step, after the ethanol and carbon dioxide produced, it will then undergo the distillation process to separate the ethanol, carbon dioxide and also water.
So I will continue with the carbon balance. As onion plants grow, they absorb carbon dioxide from the atmosphere through photosynthesis. These carbons get stored in the plant as sugar and cellulose, which are the same components that we later use for make bioethanol. Once onions are processed for food, the leftover waste, these stored carbons become our input for bioethanol productions. During fermentation process, microorganisms such as yeast will convert sugar into bioethanol and carbon dioxide. As we can see, carbon dioxide is released during fermentations, but we have to know that carbon dioxide in this process is biogenic, which is produced from renewable resources, not fossil based. So we're not adding any new carbons to the atmosphere. This shows that this process is a carbon neutral and we can balance the carbon.
In conclusion, agricultural waste, which particularly from fruit and vegetables like onion, can efficiently converted into valuable product like bioethanol, lactic acid, and deallulose by enzymatic saccharification process without pretreatment. So we can achieve high conversion of sugar by optimizing enzyme usage and the removal of the lignin. This can lead to sustainable and cost-effective approach for convert waste into high-value product.